type of the system. Suppose open loop transfer function of a system GSHS is equal to 1 plus STA 1 plus STB 1 plus STM and so on divided by s to the power n 1 plus ST1 1 plus ST2 so on. So the power of the free S is called the type of the system. For this system, the type of the system is n equal to n. Type of the system is n here. Is n. So suppose there may be a type 1 system, type 2 system, type 3 system. So for example, type 1 system GSHS equal to 1 plus 2s divided by s into 1 plus 3s. This is a simple example of type 1 system. For type 0 system, GSHS will be 1 plus s divided by 1 plus 5s, because it can be expressed as 1 plus s divided by s to the power 0 1 plus 5s. The power of the free s is 0 here, that is why it is type 0 system. So type 2 system similarly, GSHS is equal to suppose 1 plus s divided by s square 1 plus 3s 1 plus 7s. It is type 2 system. Error constants. Number 1, position error constant. It is limit s tends to 0 GSHS denoted as KP. Number 2, velocity error constant. Denoted as KV equal to limit s tends to 0 SGSHS. Number 3, acceleration error constant. Ka is equal to limit s tends to 0 s squared GSHS. These are the 3 error constants which is generally used to analyze the time domain of a second order system. Now, steady state error. ESS is equal to limit s tends to 0 s ES. What is ES? Suppose closed loop system is there. This is GS, this is error signal ES, RS, CS, and this is feedback HS. For this system, the transfer function CS by RS is equal to, according to formula, GS divided by 1 plus, it is negative feedback, 1 plus GSHS. Now, What is CS? CS equal to ES into GS, because it is clearly mentioned here. CS equal to ES into GS divided by RS is equal to GS divided by 1 plus GSHS. So GS will be automatically cancelled. So ES is equal to RS divided by 1 plus GSHS. So putting the value of ES here, so steady state error becomes limit S tends to 0 is RS divided by 1 plus GSHS. Now for the unit step input, ESS is equal to RS become 1 by S, limit S tends to 0, 1 by S divided by 1 plus GSHS into S is equal to limit S tends to 0, 1 by 1 plus GSHS. That is equal to 1 by 1 plus limit S tends to 0 GSHS is equal to 1 by 1 plus K. Now for the ramp input, the ramp signal at t is equal to t taking Laplace transform RS is equal to 1 by S. For ramp input, RS become 1 by S. So steady state error ESS is equal to limit S tends to 0 RS divided by 1 plus GSHS S. So now limit S tends to 0 S 1 by S 1 by S square 1 by S square divided by 1 plus GSHS is equal to limit S tends to 0 1 by S divided by 1 plus GSHS limit S tends to 0 1 by S plus S GSHS is equal to 1 by limit S tends to 0 S GSHS is equal to 1 by kV. Now for parabolic signal, PT equal to 0.5 t square, taking Laplace transform PS equal to 1 by S cube. So steady state error ESS limit S tends to 0 is 1 by S cube divided by 1 plus GSHS is equal to limit S tends to 0 1 by S square divided by 1 plus GSHS is equal to limit S tends to 0 1 by S square plus S square GSHS is equal to 1 by limit S tends to 0 S square GSHS is equal to 1 by K. Today I will discuss about time domain response of the second order system. This is the simple output response of a second order system. Two axes is there. One is horizontal axis, that is time axis, and another is vertical axis, is the output of the second order system, that is CT. Now the response of the output of the second order system is showing by blue line here, and the red line is the input, unit step input is given to the system. So when we are discussing about the response of the second order system, we have to study certain parameters. The first parameter, that is delay time, TD. What is delay time? Delay time is the time required for the response to reach 50% of its final value from the very first attempt. That is, 50% of the final value means 0.5. From 0 to the time required for the response to reach from 0 to 0.5, that is clearly denoted here by TD. Now the rise time. What is rise time? Rise time is the time required for the response to rise 0 to 100% of the final value for the undamped case, and 10 to 90% of the final value for overdamped case. 10 to 90% of the final value is considered here because it is an overdamped case. Now that is 0.1 to 0.9 is denoted as clear. Now this is the rise time. Now the peak time. What is peak time? It is the time required for the response to reach peak of the output response. That is denoted as TP. TP is the time required to reach peak of the response. Now the next, that is peak overshoot, that is MP. What is peak overshoot? It is the deviation of the response from an above 1 to the peak, that is denoted as MP. MP is the peak overshoot here. Now settling time. It is the time required for the response to settle down, denoted as TS. Now steady state error. It is the error to become steady of the system, that is steady state error, ESS. The general form of transfer function of a second order system is Cs by Rs is equal to omega n square divided by a square plus 2 delta omega n s plus omega n square, where omega n is the corner frequency, delta damping ratio, and a square plus 2 delta omega n s plus omega n square equal to 0 is the characteristics equation. Now number 1, there is rise time, TR. TR equal to pi minus beta divided by omega d, where omega d equal to omega n root over 1 minus delta square, and beta equal to tan inverse root over 1 minus delta square divided by delta. And beta is in radians. Next formula, that is peak time, that is Tp. So Tp equal to n pi divided by omega d, where n is the number of peak Number 3, percentage overshoot MP is equal to e to the power minus pi delta divided by root over 1 minus delta square into 100. This is percentage overshoot. Number 4, settling time TS equal to 4 by delta omega n for 2% criteria equal to 3 by delta omega n for 5% criterion. Steady state error is denoted as ESS is equal to limit s tends to 0 SES, that is limit s tends to 0 SRS divided by 1 plus GSHS. This is called steady state error. Now, steady state error. ESS equal to limit s tends to 0 RS divided by 1 plus GSHS. This is called steady state error, ESS. Now let us consider a problem that is CS by RS is equal to 500 divided by S square plus 15S plus 500. We have to find number 1, rise time, number 2, peak time, number 3, percentage overshoot, number 4, settling time, number 5, output signal, CT, number 6, steady state error. Now, comparing with the general form, a square plus 2 delta omega n plus omega n square equal to 0, we get omega n square equal to 500. Now omega n equal to root 500, 0.22.36 radian per second, and delta equal to 500 divided by 2 into, this is 15 divided by 2 into 22.36, that is 0.335. Delta is called the damping ratio and omega is called the corner frequency. Now the first parameter, that is rise time TR, you have to find out omega d. Now omega d is equal to omega n root over 1 minus delta square. Now that is equal to 22.36 divided by root over 1 minus 0.335 whole square. That is roughly equal to 21.06. Now for beta. Beta equal to tan inverse root over 1 minus delta square divided by delta. That is equal to tan inverse root over 1 minus 0.335 whole square divided by 0.335. That is equal to 1.22 radian approximately. Now with the help of the formula, TR equal to pi minus beta divided by omega d, that is 3.14 minus beta, that is 1.22 divided by omega d, that is 21.06. TR can be calculated easily. There is 0.091 second roughly, approximately. This is the rise time here. Now peak time. TP equal to n pi divided by omega d. For this particular problem, n equal to 1. So formula becomes pi divided by omega d, that is 3.14 divided by omega d, that is 21.06 equal to 0.14 second approximately. This is peak time. Now for percentage overshoot, percentage NP e to the power minus pi delta divided by root over 1 minus delta square into 100. That is equal to 0.327 into 100 is 32.7 percentage. This is percentage overshoot. Now for settling time, TS, settling time equal to 4 by delta omega n, that is 4 divided by delta 1 means 0.335 into 22.36 equal to 0.53 seconds roughly. Now steady state error. ESS is equal to RS divided by 1 plus limit S tends to 0. SES RS 1 plus GSHS into S, that is limit S tends to 0 S into, if unit step input is given, that is 1 by S divided by S square plus 15S plus 500, that is limit S tends to 0 1 by S square plus 15S plus 500, that is 1 by 500. Now, to find CT, CS by RS equal to 500 divided by S square plus 15S plus 500, or CS equal to 500 divided by S square plus 15S plus 500 into 1 by S. So it can be written as 1 by S minus S square plus 15S plus 500 S plus 15. Now 1 by S s square plus 2 into s into 15 by 2 plus 15 by 2 whole square plus 500 minus 15 by 2 whole square s plus 15 1 by s minus s plus 15 divided by s plus 15 by 2, that is 7.5 whole square plus 500 minus 225 divided by 4 1 by s plus 15 divided by s plus 7.5 whole square plus 2000 minus 225 divided by 4 1 by s minus s plus 15 7.5 whole square plus 4 that is equal to 1 by s minus s plus 15 divided by s plus 7.5 whole square plus 21 square. It is equal to roughly 21 square. Now taking inverse Laplace, Ct equal to 1 minus e to the power minus 7.5t cos 1 into cos 21t plus 0.357 sin 21t. This term has to be combined together. How it can be combined together? Suppose it is a right angle triangle. The perpendicular taken as 1 and base is 0.357. So hypotenuse becomes 0.357 whole square plus 1 square. That is 1.06. So it should be multiplied by 1.06. The expression becomes this: cos 21t plus 0.357 1 by 1.06 sin 21t. Now if it is, this angle is alpha, the sin alpha is equal to perpendicular by hypotenuse is 1 by 1.06 and cos alpha is equal to 0.357 by 1.06 and alpha is equal to sin inverse 1 by 1.06 is approximately equal to 70 degree. Now for the expression 1 minus e to the power 7.5t 1.06 sin alpha cos 21t plus cos alpha sin 21t, that is 1 minus e to the power minus 7.5t 1.06 sin alpha plus 21t 1 minus e to the power minus 7.5t 126 sin 21t plus 70 degree approximately. It is the ultimate signal Ct.